value of a number is how far is that number away from 0. So when we're talking about absolute value inequalities, the same idea, but it's inequalities. So we're looking at less than or greater than that distance away from 0 is what we're looking at. So when we look at absolute value inequalities, we've got to decide, is it an and problem or an or problem? Those were the kind of compound inequalities that we had back last week. So and or problems are what absolute value inequalities are going to turn into. And we've got to be able to determine which one it is, then set it up and solve it. Okay, so and problems are where the answers on an absolute value or on a compound inequality. And problems, where are the answers? On the inside or on the outside? Inside. Ands are on the inside because that was in between. Remember, those were the sandwiches. And problems were sandwiches, so you had stuff in the middle. So if we're thinking about the inside of distance away from 0, so here's 0 right there in the middle. If the answers are inside, then that's going to be like this area in between, right? That idea. So this distance, say this is the number 6, maybe that's -6. What do we know about all the numbers from to the left of 6? What are they to 6? Less than or greater than? Less than. If they're to the left of 6, they're less than it, right? Okay, so an and problem is going to occur when we have a less than symbol. Maybe we got absolute value of x plus 7 is less than 14. That less than symbol tells us that this is an and problem, okay, because it's a less than. Because when we're talking about distance away from 0, if you're less than a distance, that means you're getting closer to 0. So that would be the numbers in the middle, okay? So that would mean an or problem would have what symbol in it? Greater than. This greater than symbol tells us it's an or problem. Less than symbols, less than or equal to, also and problems. Greater than symbols, or problems. And there's a little saying that I use. Land of gold. Less than, or and, land, less than, and. Gore, greater than, or. Land of Gore. If you'll remember that, that'll help you remember less thans are ands, greater thans are ors. Okay? Because greater than, if we went to greater than 6, it'd be going to the outside. Remember, or problems had answers that went to the outsides. Okay? So when we look at an inequality problem, we want, or an absolute value inequality problem, we're going to look at the absolute value on the left side. We're going to look at that symbol. If it's a less than or a less than or equal to, it's an and problem. We're going to set it up as an and problem. If it's a greater than or equal to, it's an or problem. And we're going to set it up as an or problem. Okay? So we've got to decide that first before we do anything else. All right? It don't matter. Take them out of your ears. All right. Let's look at some examples. Start easy like we did yesterday. Absolute value of x. Nothing really fancy going on inside of the absolute value. It's just absolute value of x is greater than or equal to 6. Is this an and problem or an or problem? Why? Because it's greater than. That's an or problem. So this tells us that it's or. So what we do is set it up as an or problem. So that means just like yesterday, we're going to have two problems to solve. Okay? We're going to have x is greater than or equal to 6, or x is less than or equal to -6. Okay? You're going to change the sign and flip the symbol. Change the sign and flip the symbol. Change the sign, flip the symbol. Now, there's nothing to do to solve that one. We already got x's by itself. The next ones we're going to do, we'll have to do some work with that. But here we've got an or problem. Those are our answers. When we graph that on a number line, what goes above positive 6? Open circle or filled in? Filled in because it's got equal to mark, right? X is greater than or equal to 6. That means we're going to go to the left or to the right from that dot. Greater than, what numbers are greater than 6? 7 and 8. So I'm going to go toward those. And then above the negative 6, open or filled in? Filled in. And what numbers are less than that? To the left. Remember, OR problems, the answers went to the outsides. That's what we did last week. So we're taking an absolute value inequality and we're turning it into what we've already done before. And that's how you set up and solve these. Okay, let's look at absolute value of X is less than 8. So again, another simple one that doesn't have any, algebra going on there really, other than deciding is it an and or an or problem. It's an and because we got a less than. Land of Gore, less thans are ands, greater thans are ors. So less than is an and problem. How did we set up and problems last week? How could they be written? Like what? Like a sandwich, right? So what we can do is we can set up a sandwich. What symbol was on the other side always? What was always in the and problems? Less thans or greater thans? Which one is this? It's a less than. So this is a less than there. And then we put negative 8 on that end. Anytime it's an and problem, you can set it up as a sandwich. Opposite sign, less than symbol, X, or whatever's inside the absolute value, less than symbol, then the number. So we're going to set them up like that. That's already done. The X is by itself. Don't have to do anything. When I put that on the number line, I'm going to help myself out here. Negative 10, negative 8, negative 6, negative 4, 2, 0, 2, 4. What goes above the negative 8? Open circle or filled in? Why? It ain't got the bar underneath the equal to mark underneath it, so it's open. And above the positive 8? Open. Where are the answers to and problems? In the middle. That's how you graph that. Okay. Open circles because they're less thans, don't have equal to mark. Answers are in the middle because it's an and problem. Let's get to some where we actually have to do the work to get that inequality going. Let's say we had absolute value of 2x is greater than 10. The first thing you need to look at here is just like yesterday. If it's an absolute value problem, you need the absolute value part by itself. Is the absolute value part by itself for this problem? Yeah, there's nothing on the outside of that absolute value, right? That on the same side. 2x is on the inside. There's some stuff in there, but there's nothing on the outside of it. So because that's what's going on, we can go ahead and decide, is this an and or an or problem? It's an or because greater than. Greater than tells me it's an or. So I'm going to set up two inequalities separate because it's or. One of them is going to be just take 2x and put it greater than 10. So it's the same as the original problem. You just take the absolute value marks off of it. Okay? What's the other one? Less than negative 10. Flip it, change the sign. Flip it, change the sign. All right, so 2 separate problems, work them individually, get your 2 answers. All right, so how do we solve that first one? Divide by 2. Do I need to flip the symbol? No. When do I flip it? When you divide by negative. So I didn't divide by negative, so I just leave it x is greater than 5, or do the same work on the other one. X is less than negative 5. I'm going to make myself a little easier number line there. In practice today, you'll have number lines already there. Make them up yourself. So above the positive 5. Open circle. Open circle, good job. Going which way? X is greater than 5, so that would be going toward the 10 to the right. Above the negative 5, an open circle going to the left, because it's less than that way. Say we had absolute value of 3x minus 7 is less than or equal to 16. Okay. That's an and problem. How do you know it's an and problem? It's less than. The absolute value part's by itself. So we can go ahead and decide. We look at that. It's a less than, so that's an and problem. Very good. Okay. So when we set up an and problem, we're going to make a sandwich out of it. So we got 3x minus 7 is less than or equal to 16. On the other end down here, we're going to put another less than or equal to symbol and then put negative 16 there. That's how you're going to set those up every time. Okay? It's not ever going to be any different. You get to Algebra 2 and you do these, it setups the same way. It doesn't change ever. Okay. Now, a little bit more work to do on this one to get x by itself. So what do we do first? Plus 7 everywhere. That's right. That's going to give me 3x in the middle. 16 plus 7 be 23. And then negative 16 plus 7 be negative 9. Divided by 3, yeah. So negative 9 divided by 3 is negative 3 is less than or equal to x is less than or equal to 23, and 3 don't have anything in common, so I'm just going to leave it that fraction, 23 over 3. On my number line, above the negative 3, what should there be? Closed circle. And above the 20, where's 23 over 3? What's it close to? How many times does 3 go into 23? Doesn't go evenly, but it'll go into its sum. 6 times 3 is 18. What's 23 minus 18? It'll go another time. So 7 times. So 23 over 3 is 7 2/3. So it's close to 8, but it's between 7 and 8. So that's what I'm going to do. I'm going to go between 7 and 8, go about 2/3 of the way, and I'm going to put a mark and say that's 23 over 3. And I should have a closed circle above it. Okay, so that's what I want you to do with the fractions. When you get fractions as answers, get what they would be as a decimal or a mixed number. Go to that spot and put a mark there. And then answers for an and problem are where? In the middle. Oops. All right. Absolute value of x plus 3 minus 2 is less than or equal to 6. I got to move the 2 over there with the 6. That's right, because I need to do what first? Make the absolute value be by itself before I do anything else. So the absolute value of x plus 3 is less than or equal to 8. If this one's an and problem. What's our setup for this? Good job. Perfect. Okay. So this side right here is exactly the same thing that we're starting with. Just take the absolute value marks off of it. And then because it's an and problem, we go here and put another less than or equal to symbol on this end and change the sign. Always going to do it that way. Okay. And then get x by itself. Minus 3. Good. Everywhere gets a minus 3. This one works out nice. And negative 11 is less than or equal to x is less than or equal to 5. Okay. On a number line, you could have negative 13, negative 11, negative 9, negative 7, negative 5, negative 3, negative 1. Above each of those numbers should be what? Closed circles. And then answers are where? Middle, because it's an and problem. All right, let's look at another one, maybe a little bit more complicated one. Negative 2, absolute value of 5x minus 6 plus 4 is less than 16. Minus the 4. Yeah, the 4 is not attached directly to the absolute value part, so we'll move that first. So subtracting 4 gets us negative 2, absolute value of 5x minus 6 is less than 12, right? All right, I'm going to divide by negative 2 to get rid of it. Remember that as long as there's absolute value in the problem, you don't distribute ever. Okay, don't make that mistake. So here we have absolute value of 5x minus 6. And then that's a negative 6 over there. Flip the symbol. Why? That's right. That's exactly right. When you divide or multiply by a negative, right there in that blue step, we divided by negative 2. So that's what tells us to flip our symbol around, which means this turns into what? An OR problem. So again, you've got to decide that so you know how to set it up. So now how do we set this guy up? Less than positive 6 or 5x minus 6 greater than negative 6. So one of them is the same as what you start with here. Just take the absolute value marks off of it. The other one, flip the symbol, change the sign. Okay? Doesn't matter what order you write them in there. I'm not picky about that. We're going to solve each one of those. So add 6, 5x less than 12, and then divide by 5. X is less than 12 over 5, or same steps for the other problem. What's negative 6 plus positive 6? 0. Still divide by 5. What's 0 divided by anything? 0, always. Don't get into the bad habit there. If you get 0 over there, don't stop and say, oh, it can't work. It doesn't do that. That still works. You still solve it. Algebra 2 students still have the same problem. They'll get 0 over there and they'll want to stop and say it doesn't work. But yeah, it does. There, 5 times 0 gives me 0. So there is a solution to that. So got an OR problem on a number line. I know 0's got to be there and 12 over 5. Where's 12 over 5 is about what number? 2 and some change, right? 2.4 is what it is as a decimal. So I got a 0 here. 1, 2, 3. I'm just putting some numbers there. Doesn't really matter as long as I get a little bit past where I need to be. So x is less than 12 over 5. So I'm going to go to 12 over 5, which is about right there. Above it should be a what? Open circle. Which direction are they going? To the left or to the right? Left. Less than. 2 is less than 2.4, so I'm going to go toward 2. And then above the 0 should be an open circle, right? And it's going to the right. Does that look like our OR problems normally do? No. But are they going in opposite directions? Yeah. Still, that's okay. That works. Okay. Now, here's what's special about this one. This graph is correct. Those answers are correct. But this one has a final answer of all real numbers. Because are there any numbers that are not red or green? No, everybody's covered. Even these open circles that are supposed to mean you don't count that number, they're covered by red. Like this one is covered by the red part. This one that's open here is covered by the green part. So this one has a solution of all real numbers. Not very often that happens. That's going to be a rare occurrence for you to get something like that happening. So if you end up getting 2 or 3 of these happening on the practice that you're getting today, it's not very likely that that's happening. Okay, it should once every now and then is all that's going to happen. That doesn't happen very often. Okay, all right. Let's look at one more. -3. Absolute value of 2x plus 5 is greater than, oh, excuse me, sorry, I forgot the -4, greater than -10. There we go. Do what? That would be the first step? Yeah, first step would be +4. Good job. So there's -3, absolute value of 2x plus 5. And that'd be -6. Dividing by -3. Absolute value of 2x plus 5 is 2. And what about the symbol? Do I flip it or keep it the same? Flip it so it makes it an and problem. That's the key here. Is you can't decide that until you get done. And don't forget, divide by negative. Got that going on. Okay, so set up as an and problem. How's the setup go? Good job. That's exactly right. A sandwich, make your sandwich because it's an and problem. And this side is exactly what you start with. The other side, put a less than and change the sign. Got to subtract 5 on both sides. That'd be -7 less than 2x less than -3. Divide by 2. Well, that doesn't go evenly into any of that. So we got nothing but fractions. Everybody's favorite. Okay. So there's our inequality solution for that. Let's graph that on a number line. Orange is not a good color. You can't really see it well. Let's make it change it. Purple, you can see that. All right, now, so we'll put that on a number line. Where should our answers be? In the middle or outside? In the middle, because it's a what kind of problem? It's an and problem. So our answer should be in the middle. So Negative 7 over 2. What's it close to? It's close to negative 3. Is it past negative 3 or so it's negative 3.5, right? So I need negative 4 there. Negative 3, negative 2, negative 1, 0. So I just filled in the rest of it. Okay, so I know 7 over 2 is right there. And then negative 3 over 2 is negative 1.5, right? So right there. What goes above each of those? Open circles. When you're dealing with absolute value inequalities, they will always have the same kind of circle on the graph. You're never going to have different, one closed and one open. They're always going to be both the same. And the answers are where? In the middle. Not very complicated. If you can do, setup's the key. Make sure you decide and or before you start working there, and you got it. That's not for you. Brown Academy doesn't subdivide this real good, so that's why we're doing all that paper stuff. These, how they were doing. For anybody that needs one from yesterday, maybe misplaced yours or cut out of your binder or something. Ready? Yes, ma'am. Hey, brother, turn around. You're still gonna get it. Turn around. Get your neck. Yeah, bro. I thought I almost copied that. And you missed. Yeah, I did. Is it hot in here, you guys? No. No. Said the guy with the jacket on. Mr. Did I tell you yet, Mr. You did look at the same one. Yeah. No, we gotta get invites. So I'll get one of those, get invites. Did I tell you yet? Change my identity and move into, anywhere but here? No, I'm not moving here. You're not moving here? I'm like, it's gonna be difficult to do because you're already here. All I'm doing now. Hard to move back here. Never left you. Where are you gonna look? Where are you gonna move to? Arizona. I'm going to say, I don't know. Pretty good idea. So. Andrew or Paul? And everything. I think it's how to get away driving. Yeah. Or, that's correct. So you're going to set up two different problems with the or between them.